Welcome back, guys. We were discussing about application IoT application layer protocols in our previous session. Now we'll discuss about IoT application layer protocol with respect to topmost. So in the last class we have seen SCADA, supervisory control, and data acquisition as good old application layer protocol, but it is adopted in the few years uh, back, and we have seen some of the scenarios where it can be implemented. So coming to the application layer protocol, that is CoAP and MQTT. So let us have a look into this particular diagram. So we'll start from the bottom. 802.15.4 physical layer, 15.4 MAC, 6 LoWPAN, IPv6, TCP and UDP. So these 5 layers we already covered. To brief with that, the basic one 802.15.4, that is a physical level or endpoint level or the tail end level. Over here, what we do with respect to our smart object as an IoT is this physical layer is nothing but where we can have the data in the form of binary, or in general we can say binary, but where the sensors, actuators and the hardware connections come to picture in this particular layer. Coming to MAC, the data is transmitted over this one media access control layer using 802.15.4 as a standard. From there we have our own low power consumption. With low power we have wireless private area network, our own network. It is adopted under IPv6. Then we have IPv6 so that we can have more number of sensors, more security, more involvement. Over that we have transport protocols, UDP or TCP. UDP, datagram protocol, can read the data in the form of datagram, connectionless protocol, and there is no guarantee that the data is delivered to the other end. Coming to TCP, it is a connection oriented protocol or circuit switched network protocol, or we can say there is a dedicated line from sender to receiver before the inception of the communication setup, and we can guarantee that the data is delivered to the destination. So these are the things we already covered. So now coming to the IoT application layer protocol, there is 2 dedicated application layer protocols that as an IoT can be used. For constrained nodes, for constrained setup, we can have CoAP, constrained network application layer protocol, CoAP and MQTT. We'll see in detail about these two. So when considering constrained network and or a large scale deployment of constrained nodes, we have web-based and data model protocols. But coming to IoT industry is as a part, so we should work on a lightweight protocol. Why we need lightweight protocol? So that it is easier to handle, easy to shift, easy to migrate. Right. All based on these many constraints, we are going with the lightweight protocols so that we can be best suited to the large number of constrained nodes and networks. Because for an example, as a smart object is concerned, individual smart object may have number of sensors and actuators on that. So each number or many number of sensors can be controlled via using a single tiny computer, say Raspberry Pi, Intel Galileo or Arduino kit. So now to deal with this number of sensors, we need a specific application so that it can handle all these data, sensor data using an user interface. So that is a use of lightweight protocol in that area based on number of constrained nodes and networks are increased. So that's why CoAP is one of the major application layer protocol when we are making use of constrained network and constrained nodes. So this is an protocol IoT protocol stack for CoAP and MQTT. So both CoAP and MQTT are the IoT application layer protocol, dedicated IoT application layer protocols. We'll see CoAP in detail. So CoAP is nothing but constrained application protocol. It is for constrained, and it resulted from IETF, constrained restful environment, that is core. So we are very much familiar with the REST protocol. So this is developed, CoAP developed on top of that, follows that particular criteria, saying that core working group's efforts to develop a generic framework for resource oriented applications which targets constrained nodes and network. So that is the idea behind that. So when we have constrained nodes and networks, that is to be handled for the core industry or core deployment, we need to have a proper environment that is to be handled using a proper framework, generic framework. So when we develop a generic framework using those, that is using a REST environment, there should be a resource oriented application. So resource oriented, why we are stressing resource is in the sense, each resource are nothing but sensors and actuators or whatever the device we use in that network, constrained network. So that those network from those data which is sent from the constrained nodes and network, that is to be handled carefully. That's why we need to have a dedicated constrained application protocol only to handle and only to deal with the data which is sent or which is forwarded to and from by the constrained nodes and networks. We need a dedicated application. So that is the constrained application protocol. So this particular CoAP, constrained application protocol, is built based on a framework, CoAP framework, so which defines simple and very flexible way or flexible manner to manipulate with sensor and actuators for data as well as device management. So here two part is supposed to concentrate more. So that is the CoAP, please follow the second point. CoAP framework should define simple and flexible manner so that sensors and actuators data can be handled and device also can be managed. So we supposed to stress more on data and device as we are making use of tiny sensors, tiny actuators, tiny computers as well. So when we concern with the data, so these sensors may sense the data and send those data to the upper layer. So this sensed data is processed data based on the processing or based on the application. We may send some commands to the actuator. So actuator will perform some of the actions. Again, the data performed actions data is collected and sent back to sensor. This is a cycle. So now, based on that particular data, the data should be managed. What is mean by manage? Data should be collected, data should be converted to other format, data should be stored in the server, data should be sent to the presentation level to the consumer, data should be stored in the cloud. All those come to the picture. Along with that, when we say device management, is supposed to go through with the specification of device as well. On the other hand, based on the usage, we categorize different sensors. The sensor that we use in environment, the sensor that we use in the sea, the sensor that we use in a vehicle, all those. So based on the life of the device is concerned, the device should be managed. So these things can be easily or in a better manner can be handled via CoAP framework. That's why we opted with CoAP. Hope you understood the situation. More number of data should be collected, more number of data should be processed, more number of data should be stored, more number of data should be sent to presentation level to the user. and all the devices, including sensors, actuator, computers, all should be managed in a better manner. So COAP framework will give us that particular manner or setup. So to do with that, how we manage to collect those framework. So for that one, we have IETF core working group. So now IETF core working group set some standards and specifications for COAP. So that is first one, RFC 6690, that is constrained restful environment core link format, specific format, link format is available. Then RFC 7252, we have a constrained application protocol, COAP. RFC 7641, that is observing resources in constrained application protocol. Then 7959, that is block-wise transfers. 8075, that is guidelines for mapping implementations. So now concentrate more on these things based on this data and device management. So that is why I have stressed more on data and device management, because the data can be collected and handled over a particular environment. So that is, and that environment is defined in this particular standard RFC 6690. So based on that, is supposed to develop data handling mechanism. That is what we involve, why we involved RFC 6690. Next one, 7252, we have an application protocol, dedicated application protocol we have. So to deal with these sensor data, tiny data, we need dedicated application. So that is adopted from this. Then to handle not only collection of data, to handle with that particular data, to handle with the device, we need observing resources. There should be a standard protocol. Using that particular protocol only, the resources are observed in the constrained application protocol. So when we say observing resources, in the sense whether we can take an example of whether temperature is increasing in that particular system temperature, or life of the device, or power management, all those comes into picture when we say device management, all those parts. So these definitions are covered in this particular RFC. Then we have blockwise transfers. So these blockwise transfers are concerned with the data management. So when you want to transfer the block of data together, consider you have a more than 50 sensors in a particular device, all those 50 sensor data should be transferred from one end to another. Then you should follow some standard that is written in 7959. Then we supposed to map from one end to another end. That is why we used map T in SCADA. Same thing, we need to make use of mapping techniques. That is HTTP to COAP, hypertext transfer protocol to constrained application protocol as a front end or as a browser. So there is a guideline in this 8075. So this is how COAP is built. We'll see little more about COAP. So now how that message format looks like. So we have a COAP message format like this. Entire length is of 4 bytes. On top we have version, we have TKL, code, message. We'll see one by one each. So T in the sense whether we have a token, yes or no, there is of 1 byte. If it is yes, it is 1. If it is no, 0. Token length supposed to specify. Then code, after that message ID. This is either sequence number or any ID. Then the actual token. So over here, actual token is optional. So the length is assigned by TKL. So depends on the length, the token is assigned. If there is a continuity, if there is a continuity, there should be specific TKL should be already defined. Then we have other options. These options may include either padding, or say for example, if you are connecting more than one tiny computers together, then if you are using different models in the tiny computers. For example, if you consider Raspberry Pi, there are Raspberry Pi model 1, model 2, B, model 3 now, all these. So if you are managed to have model 2 with model 3, model 3 with model 1, all those, right? So there should be an option. So this option is nothing but padding or something like that. Adjustment kind of thing we can add out here. Then we have a payload. Payload is again optional. So payload is nothing but actual data we can have. So this is about CoAP message format. With respect to message format is concerned, is supposed to follow this particular entire structure. So this is written in guidelines. If you want to map from one level to another level, from HTTP to our tiny computer methodology, constrained application protocol, then we should have this mapping structure. That is what we can write over here, right? So this is CoAP message format. Continuing further, CoAP communications in IoT infrastructure. So one of the best suitable example for an industry. So communications, constrained network communications, application layer protocol. So now please look after the diagram. We have the person who will look after this entire setup. So his job is to trace out what are the things happening in the backend, right? So when we say the backend, again backend in the sense based on the CoAP format, So with respect to version, it may vary. So version is identified by that the facilities used in that particular network. T uses type, whether it is message type you can specify, whether you want acknowledgement, whether you want non-acknowledgement or no need of acknowledgement or confirmable or non-confirmable, all those things. And coming to the code part, it is in the code part, this one, please follow my cursor. Code part highlights there is a request methodology. So for a request message, there should be a need of response on the other end. So that particular coding part we can include. Message ID. So message ID to track with the data duplication or serial or to join in the other end. And then this particular token is nothing but based on the token length, whatever the token length is specified here, that much token must be correlated over here. And coming to the options, it may be options, option number, length, and some of the values, padding, and based on the size and the request, it may change. Payload is nothing but a carriers. It will carry the data. It is again optional. So these are the fields. So now consider these fields once again, and we are trying to fetch the result. So now CoAP message across the network IoT infrastructure. So it may take various paths. Various paths in the sense maybe it may carry HTTP, CoAP, CoAP, and CoAP. Anything, either HTTP or CoAP. So connection between devices and the other things are located on the same connection between different constraint networks. So here we have different network, here we have different network, here I have different network. So these from different network to this particular network can be managed with any type of communication setup. Say either we may have cloud server, either we may have proxies or HTTP, basic HTTP mapping from the machine to the proxy or IP, normal IP based protocols, right? So these are the things it may happen in the backend. So now we may go with the CoAP based REST protocol as well. Say if you have client server mechanism, then the REST setup is well suited. So we can have URI, uniform resource identifier, to that particular server and identifies the individual resources. So the server should be responded to that particular request as a response code. Will present the resource representation as well, and how to present that either with respect to get method, post method, put method, and delete methods. So with respect to that, we have a setup over here. So with respect to this setup, defines 4 types of messages. So we consider a situation. We have a utility operation center. Please look after the diagram. So we have a utility operation center. So this operation center is for clients. So client will log in into the environment and it looks after the details, tracing out different utility, using out different data from the server. So now using get method, you please follow the diagram. Using get method, the client requests there is a there should be a connection to server. So if the connection is already established, he'll request the particular data saying that I need this particular temperature data from the server. So now server's job is to identify the client first. If the client is genuine, like proper user credentials, then the connection is established. Then after sending acknowledgement or together with the acknowledgement of reception of this particular request, connection request, it will send the temperature data to the client. So now please observe, we followed a connection request with the number. Server sent with the same number as it is acknowledged. So now CoAP message ID is 0x47. So we have a message ID here. This is how message ID is determined with respect to CoAP. So now when CoAP defines 4 types of messages: confirmable, non-confirmable, acknowledgement, and reset. So now with this particular kind of example, this is acknowledgement based because the server should send the acknowledgement, and along with this it may give you other response codes as well, CoAP code, and which method is adopted, which options is included, what is the content format, all those can be shared between this. Then if a recipient is client now, so if client cannot acknowledge this one, by default it is observing that the server observes that it is delivered or reached on the other side, because we already have a connection establishment request. This is how this is how the CoAP works. So any clarification on any doubt in this CoAP, please go through with this and get back to me. We'll discuss other protocol MQTT in the next session after a while.